Hello everybody, my name is Chris and we are going to be making together a Google App Engine application using the Go programming language. We're going to make it from scratch. I haven't done any of this beforehand and it'll be a lot of fun. The app I have in mind, if you remember Light Bright from your childhood, or if you have children that might be in front of you, we're basically going to make that for the web so that anyone can use it. It'll be a communal Light Bright style game that we'll call Light Grid, and it's going to be a lot of fun. What you see in front of you right now is the current website for our app. You can see it's really, well, it's telling us to make our app, so let's go ahead and do that. For those of you who haven't seen it before, this is the dashboard. This is sort of where you get your statistics and you can see all the components of what's going on behind the scenes in your app, and it will prove very useful in the future, but for now we can sort of ignore it. Alright then, with all that said, let's get started. So to begin with, we have in front of me our template for, generic web apps. And this is, since we are making a light grid, let's change the name to Light Grid in the title. And we're going to say in our welcome to our new app, we're going to change that to Light Grid again, because it's nice to see in the body itself what you're looking at. And just as a reminder, I'm going to say that the actual light grid here goes here. Okay, and we're done. And apologies for the case mistake. So having done that, to update the app so we can actually see it on the web, just go into our command window, go to whatever folder you're doing it. I'm doing in the apps folder, so like you can see here, it's C drive /apps /lightgrid / blah 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 blah. Okay, so it's enough to just go to your apps folder, if the folder before the actual program. And in your apps folder, g.py update, what did I call this? Light Grid. Okay, so running this Python file, it basically tells Google to send the app to the web, and then it'll compile it, and if you do good and there are no errors, it'll make it up to the cloud, and if there are errors, then it will yell at you and it will tell you what to fix, which is very helpful. Now what you can also do is dev app server.py. It runs another script that creates a localhost app server, just so you can see your app on locally, which if you're testing, is probably a better thing to do. I like to just send it up to the web because there are slight differences in functionality, and the web server is actually faster. So like you can see, like you have to deal with this firewall thing and all that. Is it a good way to do it? No, probably not. Probably the best way to do it is to create a test server, and then when you've got everything right, then you move it to your live server, and perfect. But honestly, we're making a light grid app that no one knows about yet, and it's just easier and more convenient to do it directly to your live production server. So anyways, as you can see from running app config, we've been able to send our code up to the web again, and now it says it tells us what the app is called, light grid, da 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 da. If you want to see what the localhost thing looks like, this is what it is. You go to localhost and then 8080 is the port, and there it is again. And yeah, that's how that works, and we'll never see that again. And if you don't approve of this style of development, please let me know in the comments. Okay, so we've got our template. Let's actually go to the Go programming. Go to the part where we make interesting things. Here's our initial file, our initial Go file. This is what tells it what to do when you go to when you go to the website, right? So when you go to this, lightgrid.appspot.com, it pulls out, it goes to the root function and asks the root function what should display. Root function takes the request, and that should be a lowercase r. Apologies if you know, and says, okay, go ahead and display the template called root to the response writer, which if you don't know what that is or don't understand it too well, it's fine, don't worry about it. We call it W, just know that needs to be there. And this is the another important part, which is that this is the variable that we're sending, or variables or structures that we're sending to the template to create custom code. Currently we're sending nothing. Currently we have no information to send to the template. So in Go, the way you do that is just say send nil, as in nothing, as in nil. So that's what we're doing. And as you can see, we called the template that we're actually running is called root, which is what this part is here, and that's why it displays. So perfect. So the question is, how do we get started with actually making a light grid? A good question, you ask. And I think the best part is to create a structure first. So in Go, there's a unique, somewhat unique method for creating complex variable types, I guess you'd say, called structures. And if you know Java or any of the other class languages, it's kind of like a class where you can mess around with it and your compiler won't yell at you, which is great. It's absolutely great. If you're like me, it's the best thing you've ever run to. But it does take some getting used to if you're used to a more formalized class methodology where everything is sort of hard coded and you have to say what it's different. Okay, so we're making a light grid, and let's think about it conceptually. First of all, there's the actual grid. It's got rows and it's got columns, and so there's a light, which is each light has a row and a column position, and it has a color, with off being a color. So off would be black, or we'll figure something out. But off is a color, and so we're going to actually need we're going to need three types of structures to represent this. First of all, there's the structure of the light itself, right? The light has, and in that structure we're going to say that what its row number is, what its column number is, and what color it is. And then we've got to deal with the actual fact that we're sort of going to be iterating through the grid and pulling each light sequentially when we're actually displaying it on the website, because that's how you're going to display it, right? You're going to go through the rows, and on each row you're going to go through the columns, and you're going to say what color is that column position in that row. So we're going to have to represent that in our structures, which we're going to do now. So the first thing we have to look at is a type for the light. So we're going to make a type light. Easy enough. And that's just saying we're defining it as the structure type as with the name of light, which is the same as being int or string or float 64. It's the name. Okay. And then there's a color, which I like to do strings for all of these things. I could see doing with an int where like 0 is black, 1 is blue, 2 is green. Or I could see like doing some hexadecimal thing where you're actually passing the literal color value in. But I just like to pass in like blue or orange, and then when we get to the actual template side, we're going to say what each of those things actually looks like on the website. So that's what we're going to do. And then we're going to pass in a row, which is an int, and a column, which is an int, and we're done. It's a very simple structure, and there you go. So the next type of structure we're going to need is, and this is a little bit goofy, but we're going to need a row structure. So which is to say, if you go again back to the whole grid concept, you're going to go through the rows, and each row you're going to look at, you know, the columns one by one and pull the light. Well, what I found works best for this with the inside of Go methodology is to just go ahead and make a row structure, and just, so I'll just show you. Type row struct, right? Oh, I spelled this wrong. Okay, and so it lights up with blue when I did it right. Good. Okay, and so in this row structure, we're going to have a column. Well, we're going to call it columns, or cols, I guess. And we're going to say that this is a light array. It's not just a light, it's an array of lights. Yeah. And then we're going to do a type grid, which is going to be an array of, which is going to have rows, which is an array of rows. And I don't know if this is the best way of doing this. This is the best way I've found, and if you have a better way of creating this type of structure, let me know in the comments. But yeah, this works for me, and for me it works very well in terms of passing it actually into the template. So, and then because then you can just loop over it in the template, and it's all peachy keen. So there we go. So we have our structures, we have our lights, and let's create a grid. So to make a grid, there are lots of ways we could do this, but we'll just start out with var grid. Done. It's defined. It doesn't have any lights in it, but it's defined. Let's go ahead and actually pass in lights. So first of all, the question is how many rows, how many columns. Let's say, let's do 10 rows and let's do 10 rows and 8 columns. Why not? No, wait, 8 rows and 10 columns. Okay, so we'll just define row count, and this as 8 and col count as 10. And if you're wondering what this means, this is, you'll see this in other languages as well, this is a way of defining the row and giving it a value at the same time. So this is basically a combination of var row count int, and then, you know, row count equals 8. So it's just a shorthand, but it's very useful, and so we are doing it. And then so now we have to actually get into slices, which is another interesting aspect of Go. So let's get to it. To make a slice in Go, it's very straightforward. You just say that the element you're defining, in this case rows, is equal to make, and then you say what type of slice it is. It's a slice of a row array. You say what the current number of elements is, which is row count, and you say what your estimated maximum is, which is also row count. The estimated maximum doesn't actually matter for our purposes, but you have to have it, so there it is. And with that, it's done. We now have a rows array. Our next step is to loop over the rows array and give each row a column array, which is an array of lights. So to do that, we're just going to say that we're going to do a for loop, which looks a little different in Go than you might see in most other languages, because instead of just looping over the index, and for each index you pull the element, and you know what you're used to seeing in terms of sort of this multi-step process, you can just use this range concept as default, and what it does is it says that for each element in rows, it's just going to go ahead and pull them one by one and give you the index, which is I in this case, and the value, which I'm sending to underscore, which is basically like the garbage can. It means that you don't care what the value is, because we're not going to be looking at the actual value. We're just looping over the, for our purposes, we're just looping over the index. But if you did want the value, you could just say for I row, and then instead of having to do a multi-step process of saying row is equal to rows bracket I and bracket, you got it there. That's great. But we're going to send it to the garbage can, which It's fine. And yeah, so the next step, we're looping over the rows, is that we're going to go ahead and say that rows I is equal to make light call count rows I dot calls. So this is saying that for each of the rows arrays elements, go ahead and define as columns as a new a light slice, and then we're going to loop over the columns there that we've just created. So next we're going to define each light element in the array. So to do that, we're just going to make a new light element. We're going to define it as light with a color of off, row of I, column of J, and that should do it. And then to actually stick that into our grid, we're just going to say rows I dot calls J equals light. And then we're going to say, go back to the actual grid variable that we defined earlier, and we're going to say that grid.rows equals rows, the array that we just made, and we're going to pass grid in to our template. And that should do it. And let's see if it worked. Alright, so beautiful. Well, almost beautiful. So the good news is that it did work. I messed up the template a little bit so that instead of seeing the column number, because it only had one bracket on the left and two on the right, instead of two on the left, two on the right, we're just seeing, you know, the dot col instead of the value that that points to. Easy enough to fix. This is a common theme, by the way, in programming, at least for me, is just basically seeing the things you screwed up and making them better, right? So step by step. And let's try it again. And there you go. So there's our array. So now that our grid is working, we've got, as you can see, it's pulling the row number, which is 0 through 7, because indexes start at 0, which is more convenient than starting at 1. If you're curious about such things, it is more convenient. Just trust me on that. And the columns are going to 9 because there are 10 columns, so 0 through 9. And our grid is populating. Our arrays are working good. So, but it's not a light bright. It's not a light grid. So let's go ahead and make it one. And to do that, what we're going to do is pretty straightforward. We're going to make a for each light we pull out, we're going to say that we're going to look at the class whose name is that light color, and which haven't been defined yet. Let's use the letter O as our, peg for now, because, kind of looks like a peg. And do that. Now, currently, all this is going to do is show a bunch of O's with, scrolling classes of off, which don't mean anything because they're not defined yet. But we're going to change that shortly. So the first thing we have to do now that we've got our dividers is to define the style sheets to actually contain them. So let's start making classes. So let's say class off. Let's see, and we would just want a simple background color of black because that's the color of off, if you remember the original light bright. Yeah. So let's just see if that works. Now if this works, what we should see is just a bunch of black squares in sort of a grid formation. So let's give it a go. No. Well, let's see why not. So the page source, okay, so it's working in terms of defining the class correctly. Oh, so there are two problems. One is that they're not spanning, and the other problem is that it's not a black background. So let's see, that's display inline block, I believe that is, which just says, like, you know, even though they're divided sections, like put them left to right instead of top to bottom, unless there's a page break or something. And then let's try this, because it is a text thing. Maybe this is what's mucking it up. I already know it's not going to work because we didn't update the style sheet over here. I should have mentioned this earlier, but if you're working with style sheets, like, one of those critical things to know is that browsers won't pull in a new style sheet automatically unless it's somehow different URL, even if you're just changing a meaningless variable, which in this case is v. So I just increment it by 1 each time, or 0.001 each time I change something. And that's just to let the browser know that it should actually pull in a new style sheet. And if you don't do that, none of your changes take effect, and you hit your keyboard for hours and hours and want to throw things. Let's give it a look. Hey! And it kind of worked. So, well, it did work. So as you can see, it's a whole bunch of pegs, a whole bunch of O's, and yeah, this is exactly what we wanted. Now, the first thing that comes to my mind is this is not nearly enough pegs. So let's make it 40 wide, maybe? Yeah, 40 wide and 30, I don't know, 8, 16, 24. Let's make it 25 tall. Okay. Alright, let's do this. The second thing that comes to mind is, I don't know if, is that the spacing should be uniform. But we'll deal with that later. So rows 40 and columns 25. Okay. Well, actually, can we deal with this spacing now? Well, for now, let's just yeah, we can deal with it. So to deal with the spacing, we'll just say what are we saying? We're saying margin bottom, I think, right? Let's say 10 p 2 pixels. And if that's, you know, if that's off, then we'll just muck with it. Keep mucking. Okay, up it goes to the cloud, and let's see. Okay, so is this really 40 wide? No, I reversed the numbers. The spacing is much better though. Yeah, if you remember the original Lite-Brite, there was a spacing issue with Lite-Brites too, in that, you know, you couldn't get the pegs too close together. I might adjust it by having a black background so that, you know, you're not getting sort of, let's just do that. Okay, so now that we know at least that the pegs work, let's go ahead and correct the rows and columns. So it's 25 rows, 40 columns, not the other way around. As a test of sorts, let's make a yellow peg. So let's just go ahead and make I don't know, grid.rows, row number 2, which is actually row number 3, if you remember the talk about 0 being an index. Columns 8, which is actually 9. Dot color, and let's make it equal to yellow. Okay. So now it's a yellow pig, and we have to teach our, let's see, template how to deal with it. So we'll update the style sheet number to 6, why not? And okay, nothing has to change here. All that has to change is that we have to add a bunch of style sheet classes for yellow, with yellow and the yellow text. So off it goes. It's not black anymore. It's yellow. Okay, so that's a whole bunch of that stuff, and then but it should be done. And we go ahead and update light grid. Make sure it works, and if it does work, we'll just go ahead and make more, a style sheet for red, green, or style sheet class for red, green, blue, white, as well as the ones we have currently. So it worked, which is good news. As you can see, a yellow background. I think though, we're going to get rid of the circle altogether. I think it's just going to be a yellow peg, or yellow square peg, you might say, and we're just going to blend the letter into the background. To do that, we're just going to go ahead and go back to our style sheet and say color yellow, which says text color be yellow as well as the background color. We'll do the same thing over here with black. Okay, we've got to bring up our update our style sheet version. Up it goes to the cloud. Okay, let's go ahead and check again, and there you go. It's yellow without any dot. You can see that they exist, but you know what? If you don't know they're there, you don't know they're there. Okay, so that's done. So we know the colors work. We know that we can place the pegs, even if right now we're just doing it through our code. And so through the magic of copy paste, I'm going to make some more classes for blue. Be a little bit of a pain in the butt. So I'm probably going to flash forward through this part, and I'll see you when it's all done. Alright, welcome back. We finished putting in the colors. As you can see, we got yellow, blue, green, red, white, and yeah. On top of that, we've updated the margins so that you can see we've taken out that margin bottom, so we're removing the space there. And I put in this grid margin at -2 pixels on a side, or I could have done -4 pixels on a single side as opposed to splitting up in half. But the effect of this is that we've put a div class of grid and to serve as the holder for our whole light board, and our new grid class for the paragraphs is being attached to the O, with the effect that now our grid looks like this. Sea of black. I think this looks much nicer than the spaced out setup we had before. I know that it's a little bit diverging from the original idea, but I think this just looks better. So that's what we have, and I think that we should test it out to see what it looks like with a bunch of pegs put into our board. So to do that, I've created a function called add pegs, which basically all it does is take our rows, and then we just add a whole bunch of pegs to the rows, and then we spit our modified row back out again, and that's how it works. So each of these lines is simply saying put that color peg in that color spot, and by using this particular line here, the grid.rows equals add pegs grid rows, we're able to say, take your original grid rows, add all our pegs that we've decided to put in, and put it back into our grid. Now these lines here, like you've seen in most programming languages, comment out this particular line, so we'll just get rid of that now. So it'll be functional. As you can see, we have a whole lot of pegs. I went a little bit crazy with this. It was a lot of fun, and I think I hope you enjoyed as much as I did. So let's see what we've got here, and we'll just go ahead and throw in another update to the cloud with taking out our comments. And let's see what comes out of it. Okay, our update is complete, so we're ready to refresh our web browser and see what comes out. And with that, we're able to say beyond a doubt that our website is working and that everything we've told it to do works just fine. We've got a light grid that defaults to black as the off color, but can handle a variety of other colors. And we're able to affix a particular pixel type to each pixel, which is an O, but is hidden. And we're able, by doing that, we're able to create this rough pixel map, or light bright light grid style design, in this case a TNT block from Minecraft. And we can say at this point that the actual display functionality is working perfect. The next hurdle, which we will address in the upcoming part 2 of this series, will be to actually create a user interface where users are able to choose a color, select pixels to color that color in, and have their changes be saved to the server so that everyone can see them and everyone can modify them. And in that way, we're going to have a communal light bright board. And I think it's going to be a lot of fun. I think it's going to be pretty neat, and I think that you guys will like it a lot. So stay tuned, and thanks for watching.